Hello, everyone.
Welcome, everybody. Glad to see that we have such a big group so early in the call this morning. Appreciate everybody joining. Today we have Robert. He's going to be presenting on ingestion patterns with AutoLoader today. Really excited to see this and get this started. Go ahead and put any questions in the Q&A box, and I'll be here to help answer those as they come in. Or if they're more appropriate for Robert, he can answer them live. Also, feel free to raise your hand if you have a question that would be better kind of, asked out loud. And when appropriate, I will unmute you so you can ask your question. And then with that, I'll let you take it away, Robert. Thank you so much.
Sounds good. Can you hear me?
Yep.
All right. Can you see my screen?
Yes.
All right. Well, I'll go ahead and get started. So first, I just wanted to take a few moments and go through a couple of slides around AutoLoader. My goal is to keep this brief. If you have further questions about what AutoLoader is, please do not hesitate to put it in the chat, and I can spend a little bit more time on it. My assumption is a little bit that you already understand some ingestion concepts and things with Databricks. This is really just sort of a refresher to highlight the things that we're going to be talking about today. So my name is Robert Mosley. I've stolen this presentation from someone else, so that's not my name down there at the bottom. I am a solutions architect here at Databricks, working with customers to be successful with things like with AutoLoader. So the Lakehouse Platform is the platform of Databricks. It's a complete solution for just about everything you can do or you need from a data solution standpoint. We have a data lake at the bottom that can facilitate just about any kind of data that you can put out in the cloud. Then on top of that, we have the Delta Lake, we have governance and security, and lots of different layers to help you manage all that data. Ultimately, it leads to being able to fulfill the capabilities that you need for the top applications. So data engineering, data science, machine learning, SQL analytics, and streaming applications. Today, in particular, we're going to be talking about data engineering. That's where AutoLoader fits into, and data ingestion and some ETL really comes from. So click through this real quick. Your typical data lake integration is your landing data. Data gets dropped into a cloud storage landing zone, and then it gets brought into Databricks. We have this medallion architecture. It's very similar to most methodologies around data warehousing. The idea is that you bring data into a bronze layer. It's the raw data that matches the source, replicated from the target or the source systems. Then you have sort of a business layer, common model, that silver layer. It's cleaned, it's enhanced. Multiple systems are brought together to create those objects. And then you have a gold layer, which is ready for reporting. It's set up for specific use cases, things like that. You can tie your dashboards and things directly to it. What AutoLoader really helps with is sort of this initial stage there, that ingestion. There's a lot of things that can go wrong when it comes to ingesting data and getting it captured into your layer. And a lot of companies will spend a lot of time and have a lot of headaches around just simply getting their data into their system. So looking at some of the possibilities here, you can miss files. You could, recycle and load previous files. You might build your own processes that end up not scaling to the place that you need, or it costs too much. What happens when schemas change? That's a big headache. Does it fail? Does it evolve with it? Do you enforce it? how do you want to handle that type of thing? AutoLoader is Databricks' solution to do all this in one package. So here it's stepping a little bit into DLT, so ignore some of the code there on the left. But the idea of ingesting with AutoLoader, it automatically infers the schema. It can pick up files directly from the directory. We can set it up to either do directory listing or to do event notification. So if a file hits it, it picks up on the event and reads from it immediately. You can set it up so that it's being triggered occasionally, running every few minutes or every few hours or even nightly, or you can set it to where it's running continuously and it's pulling the data in constantly. We're going to be looking at examples of that today. You can also do schema evolution. As columns change, it can adapt. And then also you can have a rescue data column so that if data is wrong or is unexpected, it still grabs it and holds it off to the side so you don't lose it. You can see what's out there. It also works, the schema evolution aspect works with JSON, CSV, Avro, and Parquet files. Today, we're going to be working with some CSV files that I auto-generate. This is how it looks in Python. So over on the left, you can just create a read stream. You declare the file format. You declare where it comes from. You can do transformations and such. And then that's you reading your data. And then you have a write stream where you can pick up from that read stream, and then you can set a checkpoint location, and that's what's used to make sure you're only processing your files once and you're processing them in order. I guess not necessarily, processing them all together. And then that start is what creates that write stream. So it starts streaming it in. There's bunches of additional options that are in there. You can control how many files get processed at once. You can control whether or not it just loads the files that are available now and then shuts down, or if it continues to run with no end in sight until it's stopped. So one of the big advantages of AutoLoader is that it's extremely scalable. It's very fast, low latency. It works technically on micro batches as it's pulling in these files. Each file can count as a micro batch. And it's non-stream. It's a non-blocking stream. So you can run multiple streams within the same job, sourcing a lot of different data or files directly into your bronze tables in Databricks. In addition, there's more capabilities as far as if you want to take the data and push it to multiple sinks. That's something else that we'll look at. These are just some of the features that you can enable with AutoLoader, DLT, Delta Life Tables, and more. Delta Life Tables, one reason why it comes up in the same breath a lot is it's our newest ingestion and ETL methodology to build pipelines, but its ingestion is built using AutoLoader. So it facilitates automatically creating all the pipelines and everything that you need for AutoLoader to work. And AutoLoader will source in your files, be they whatever format they're in, and consume them in. So yeah, continuous. I don't have to read all these things, but it continuously ingest your files, do CDC, DLT facilitates data quality and stuff. There's just a lot of capabilities that people usually have to spend lots of money or lots of time trying to fix and address in their ETL architectures. This is DLT. We will look at DLT a little bit today and talk about the AutoLoader features of DLT. So as you can see here, this is a brief example of how DLT might work. That very first example is the one that uses AutoLoader. So it's selecting star from cloud files. And it's grabbing the data in a certain directory, and it's a CSV. And so what that does is that creates an AutoLoader instance in the background, which is ingesting those files and bringing it into the Delta table account raw. With DLT, you can use both SQL or Python. That's some of its advantages there. Also, you can facilitate CDC, both with AutoLoader and with Delta Live tables. We're going to talk about both of those today as we touch them. And data quality is outside our scope, so that would be for a larger DLT type demo. Before I get into it, I know that was quick. I was trying to keep it to less than 10, 15 minutes. Are there any questions about AutoLoader before I jump into it? If you're completely confused, now is a good time to raise your hand and we can clarify what AutoLoader is and how it works. Because if I jump into it, it's probably only going to make people more confused as we go. Do we have any questions yet?
So far, so good.
Okay.
Hold for a sec to see if anybody wants to get brave.
All right. Well, what I'll do is I'll go ahead and show this data generator notebook. And if anybody has any questions about AutoLoader, feel free to put it in there, and we'll have a couple minutes before I start showing AutoLoader features. So what I'm doing right here is this is a notebook that I'm using. As you can tell, it's still running. It'll run continuously. It's creating CSV files for me to ingest. So it takes this path here. I'm giving it a table name. It's using that as part of the path. So that's why it's important here. Setting this up so that it could be used to demonstrate multiple tables. So this is really just declaring all the directories and everything that it has to work with. Down in here, this is the crux of it. So while it's running, and it's going to just run until it's generated 3,000 files, what I'm doing is I'm creating a bunch of CSV records that are really just random values, three rows in each file. I generate 3 records with an ID ranging between 1,000 and 1,099. The way that I do it is because I'm pulling a sample. I know each individual file will not overlap, so you won't have the same ID in the same file. There's only 3 records, so the risk was low anyway, but it does happen every once in a while. So this inhibits that, and we create 3 records with a random x-axis and y-axis, and then I provide the file name, so to speak, here. And so then it creates the file location, and then writes that out to the file location, sleeps for 5 seconds, and then goes right back through it again. So as you can tell, I've been running this for a little bit. Started it probably about 10 minutes ago. We've got quite a few files out there. The rest of this is just sort of cleanup type activity. So if we haven't had any AutoLoader questions yet, what I'll do is I'll show how AutoLoader can ingest these files and get them landed in a table. So this is my basic AutoLoader notebook. Once again, please don't let this overwhelm you, but I have a path, I have the table name, and I declare a number of variables up front that I'll walk you through here. So once again, have that we receive that path, receive that table name. The raw data location, this is the place where those CSV files are being deposited by the generator. The target Delta table location, this is where I want to create the table that it ingests into. Schema location, this is a directory for AutoLoader to keep track of the schema over time. Checkpoint location, this is where the AutoLoader keeps a checkpoint of what files it's processed and where it is, and we're going to look at some features around that as we go. So as you see right here, this is our read stream. I've broken up this read stream and this write stream into 2 different steps. So in the read stream, we're declaring that we're pulling in the CSV cloud files format. Cloud files is that AutoLoader library. Max files per trigger is 1. So that declares that I'm going to try to trigger off of an individual file. The option header, there's a header record in the files, and that's true. Schema evolution mode, I say just add new columns. I'm not mimicking the schema to change, but what I'm doing is showing the code that you would do if you wanted to evolve your schema over time. This is the schema location directory, so it knows where to keep track of those schema changes. And then this tells you where to load it, or load it from. So it's pulling the data from that raw data location. After that, what I'm doing is I'm doing some light transformation. I'm selecting all the columns, and then I'm adding this additional column, underscore metadata. And what I'm featuring here is that there's always this column of underscore metadata that's available with AutoLoader that tracks a lot of the metadata around the file that's being loaded in. And so I'm not creating this out of thin air, it's in the background, but by selecting it, it becomes part of my data frame that's being ingested. And so the data that's in there, along with this additional column now that captures all that metadata, is now in my data frame that's being read in. So this is our read stream. So right now it's just a stream of data logically in memory. And then what I'm doing is I'm taking that stream and I'm creating a write stream from it to write it into a target destination. So that format is Delta. I'm doing it in append mode, which means it's going to be insert only. It's taking these records and just throwing them into the bucket. Using this checkpoint location that I described earlier. So this tracks what files have been processed already. Option to merge schema. So basically, if the schema's changed, then it facilitates that. If I had said this was false, then it would fail if the schema had changed. My trigger right now, what I've set it to is to process every 5 seconds. That somewhat mimics the file generation on the other side that's being generated every 5 seconds. So that way it's not going to pull the directory constantly. Instead, it'll pull every 5 seconds after it's finished ingesting. And then I'm going to start and I'm going to provide the target table location for it to go to. So right now I'm just using the target table location directly. I haven't created a table on top of this location, but you can see I selected this earlier. I'm going to go ahead and select it again. I'm going to refresh the table. So I'm doing a select star from this table that we've written into, and you should recognize a lot of the columns. You have an ID, you have x-axis, y-axis, that file source column. You have 2 new columns. One is rescued data. So that's something that we talked about as far as what AutoLoader does naturally, is it tries to rescue the data if there's any errors or anything that's unexpected. As you see, we don't have any of that in our data set. Everything's being processed as expected. And then last but not least, we have that underscore metadata that I had selected earlier. And you can tell as we look at it that it provides the file path, where did the file come from, the file name specifically, the file size, and the file modification time. And that time tends to be more important. So you'll see that I'm using that in my query up above. I'm ordering by ID and then by file modification time. So as I look at this record or this query result, you can see that I have several records that match the ID 1000. And you can see this is the most recent one, and these are older ones as we go through. And then we hit 1001. And you can see this is the most recent one, and these are the older ones. So this is all great and good. I've shown you how you can take data and you can land it. But let's say this is a CDC stream, and these ID records represent a primary key. We don't want duplicates in our target table. That's not good. We don't want to append only. So with AutoLoader, you could just land your CDC stream, and then with another ETL process after that, you could facilitate a merge into a target table. But you can also do it all within AutoLoader directly. And so that's the next step that I want to show. But before I jump in to trying to do merges and CDC with AutoLoader. Are there any questions about what I showed you here as far as taking those CSV files and managing a copy directly into a target Delta table inside Databricks? The key thing to note is at this point, this is now a Delta table in Databricks, and we can work with it as we want to. Assuming there's no questions yet. I don't see any in the Q&A. Not sure if any hands are raised. Okay. So what I'm going to do is I'm going to step over to this other notebook. This one facilitates CDC. What it also facilitates is having multiple syncs. What that terminology means is that, say we're picking up one file or one file source, and we want to do multiple things with it after the fact. Maybe the one requirement that I had from someone was, hey, I want to be able to query my directory, and I want to compare it to what files I've ingested, and I want to know if my cluster is being overwhelmed, if it's having trouble catching up, or if it failed, how many files are outstanding, that kind of thing. So they wanted to be able to try to monitor it and audit it. There's features like that in AutoLoader, but I'll walk you through some of the processes of what I showed them that they could do if they wanted to, is they could ingest that file, do a CDC capture with it, land it in a table, their target table, and then they could also write out that record to an audit table to mark that they've already, or to mark that they've loaded that file. And what time and things like that. They could load other metrics if they want to into it and create sort of a central audit table that documents all these things. So the idea here is that they can ingest from one file stream and land it in multiple locations, 2 different target tables. Looks like we do have a question. I'm going to check that real quick. No, not in. So the question is the Delta table being automatically optimized as the AutoLoader stream writes? And it doesn't do that automatically. Those types of things need to be performed on the table separately. So you might have a job or something that nightly or something does that. One of the advantages of Delta Live tables is that it does do some of those auto optimizations and things like that. And so that's another advantage that we can talk through when we get to the DLT piece. With AutoLoader, you have a lot more control, but you do have to facilitate some of these types of things when you get there. How does AutoLoader help with data versioning? So it works like a normal Delta table. Every time it processes an update and does a micro batching, pushes it into the table, it's executing. In this case, it's going to be executing a merge, or in that other case, it was using an insert. It creates a new version of that table. When I run this, I can also do a describe history on it, and I can show you how that version change happens over time. Yeah, so it'll do data versioning just like your processing merges into the table or inserts into the table. So if you're loading a new file with 3 records, as I'm doing in a single batch, then that would be a new version of the table. All right, so getting back to my notebook here. Once again, same type of premise. I'm pulling this stuff through. The only thing I think that's markedly different here is I'm creating this audit Delta table location. That's going to be my second sync, the second location that I drop data into. Should be very little difference here in this read stream. What you'll notice is that I pull this in twice. Once I'm pulling it in just as metadata, and the second time I'm aliasing it as the row created metadata. And I'm going to show you a sort of little trick that I'm going to be able to pull off with that by doing that. So one thing that you're also going to see is before I get into my write table is I'm going to define some logic. This is my upsert data. So I'm defining a function that's going to be used for upserting the data. It's going to receive in the target table. It's going to receive in a data frame that represents the changes. And then it's going to receive in an epoch ID, which represents the batch, so to speak, that's being processed. So as this thing processes things in micro batches, it assigns an ID to those batches. And so I'm receiving that so I can work with it. One thing that I'm going to do right up front is I'm going to do this changes df.persist on that data frame. What that does is it caches the data. If it's not necessary, but what it saves you is that in the background, every time you pull that data frame and you write to a different sync, it's actually going to go out and reread that data. And so if you don't want to do multiple reads off of your data source off of that file, then doing something like this persist will cache the data so that it only pulls it once and it works from that cache for the rest of the process until you unpersist at the end. And so that destroys that cache. So what I'm doing right up front is I'm going to determine which columns I want to update as I merge data through. So what you'll see here is that I'm grabbing all the columns from that data frame, but I'm filtering out the ID column and the row created metadata. I don't really think it's necessary to filter out the ID, but I'm showing the use case here that when you're merging on an ID, you don't have to update the ID because the ID is the primary key that you're merging on. What I'm showing here is I'm capturing that original row created metadata, and I'm not going to update it during updates. So during inserts, it'll get written. During updates, it will not be written. And so that way it'll persist between the updates as you go. So if you have any metadata or anything you want to capture on your row that signals the original inception of that record, you can filter it out so that it doesn't get updated in future updates. So here I'm getting a data frame of distinct IDs. So one of the other things you got to be concerned about in merges, especially micro batches, is if that batch has multiple updates to the same ID in it. So I have a file. I'm updating.
It appears as though Robert is having a connection issue. We'll give him just a minute. Hopefully he can come back to us. In the meantime, I'd love to find out if anybody on the call has used AutoLoader or is using AutoLoader. Oh, looks like Robert is coming back to us.
Hey guys, sorry. I had a VPN glitch out and it took me a little bit to get it all back together. Looks like some of my notebooks are still reconnecting, so hopefully we're good. Where, if you wouldn't mind, Stephanie, where did I drop out?
I can't tell you exactly, to be honest.
Okay, I will sort of back up just a little bit and make sure that I cover everything.
Apologize, I'm multitasking.
No, that's fine. How does this look?
Yes.
So I was talking through, I talked through the cache. I talked through filtering out my IDs and my row created metadata so that we can capture fields that we created the record with, but we don't want to update that as updates are processed. So that way we can keep metadata around the original inception of the record. And then what I'm doing here is I'm dealing with the situation of if we have multiple updates to the same primary key processing at the exact same time. What I do is I'm getting the most recent record. So I'm going through the changes. I'm selecting sort of a distinct ID. I'm getting the file modification time and I'm aliasing that to update time. And I'm grouping by ID. So that way I only get one record per ID and I'm getting the max update time. Once again, aliasing at update time. And so that gives me a data frame with two columns, an ID and the latest update time. What I then do is I come down here and I join that to my changes data frame. And I basically say, hey, only give me the records that match on that ID and match on that file modification time is equal to that update time. And so what that does is it says, only give me the most recent records by ID, and it filters out anything that's too old. So if you had 3 updates come in for record 1000, it'll throw away the 2 older ones and grab the more recent one. And so this way we don't have any errors that occur because we try to update multiple records at once, or the same record multiple times in the same batch. Because if you do have that scenario, AutoLoader will just crash on that error and say, hey, can't do that. And then that file becomes a poison pill and you can't get past it without either cleaning it up or implementing logic like this. And then this is your key merge statement. So I'm using this Delta table library that exists out there. And I'm saying, okay, I'm going to get the target table using that path. I'm aliasing it as a T. So I'm basically grabbing the target table, aliasing it with the letter T. So that's my target, T for target. And then I'm merging. And so I'm taking my updates, which I grabbed right here from my changes data frame. I'm aliasing that S. So the idea is source to target. So this is my source changes, writing to the target. I'm joining on the ID. And I'm only doing updates where my file modification time is greater than my existing file modification time. So what this does is this helps if you have any records that come in out of order. So we were talking earlier about what happens if you're processing multiple changes for the same primary key at the same time. This down here addresses it if you've processed a more recent version and then an old file somehow drops in and you grab that and it has an update for the same record. Well, you don't want to update that. So this right here tests for that. And if my source modification time is less than or equal to my target file modification time, then it's going to drop that and it's not going to update. So I made up sort of a fictional delete criteria. It'll delete the record if the x-axis is equal to 0. A lot of times this is an operation column or something like that is specified as delete. And so you would say if the s.operation is equal to 0. As another note, if you had that, you'd probably filter out your operation column someplace else too whenever you're doing an insert. So like right here, this says when matched update, and it grabs that update columns, I would have removed that operation column off of this unless you want it to go in to your target. And so this says when my x-axis is not equal to 0, so basically any condition that it meets that's not a delete, then do an update. And then what columns does it update? It uses this list of update columns that I created up here. That includes everything but the ID and the row created metadata. And then there's a statement here, when not matched insert. I'm using when not matched insert all. There's also when matched update all, but because I was filtering out a couple of the columns, I used that. There's an additional when not matched insert without the all. And then once again, you can provide a column set to insert. And so this has that same condition of x-axis is not equal to 0, just because if it was equal to 0, then fictionally I'm doing a delete. And then this execute executes it. That's when the data gets written into the table. And then I drop the cache. Down here is where we look at some of the audit logic that I have. I won't spend a whole lot of time on this, but all I'm doing is I'm getting the file name, I'm getting the modification time, aliasing it as file creation time, and then I'm doing a file commit time. So I'm creating a creation time off of the file metadata, and I'm creating a commit time, which is just the date time now. So I'm basically saying, hey, at this point, it's committed it, and I'm capturing that. And then I'm bringing in that epic ID as my ingest ID. So that's my batch ID, so to speak, for that batch and that ingestion. And then I'm writing it to my audit table with these options: delta format, append only, because I'm not in a situation where I want to do a merge. So it's append only, and I'm just tracking that table is being written in there. Right here, this is a function that basically takes all the parameters that are necessary, calls upsert data, and then audit data. And so that upsert will get the data written into the table, and the audit will get it written into the audit log. So that way you don't have a commit unless you've had your upsert merge statement already written. Then right down here, this is your write stream. So everything is the same as before. You have your checkpoint location. Your output mode, it's set to update because that would facilitate a merge. There's certain options here that are no longer applicable. When you do this for each batch, if you'll notice that before I had this start location where I specified the table, now I don't. Now I just have start, and I have this for each batch statement here. This for each batch statement receives a Lambda function, and I'm basically saying, hey, with the batch data frame and the batch ID, what I'm doing is I'm calling this function with the parameters that I need. And that's what's happening with each micro batch. Instead of each micro batch being handled by AutoLoader and being written into the target table, now I'm saying for each batch, I'm going to process it, and I'm going to send it through this batch data function, which sends it through upsert data and then sends it through audit data. All right. So when I do for each batch, as I was saying, there's certain options that it's going to sort of ignore. Merge schema, output mode, all that stuff is handled by this function up here instead of being handled by AutoLoader. I kept them in there because they're in there and I didn't delete them, but just certain things that you shouldn't expect to be controlled by AutoLoader, because now you're no longer using AutoLoader to write into the target table. So I'm going to go ahead and run this. I haven't run it yet. Run everything above it. I don't need this. Okay. So we have our stream going. We're writing that data into the stream. I'm picking it up off of this exact same set of files. So all these files that have been being processed into here, are now getting processed into here. So one thing that I'll show you real quick is AutoLoader does keep track of some audit information. So I'm going to show you what it keeps track of here. It already has an example pulled up, but I'll refresh it. So as you see, it keeps track of the file that's being ingested, gives you the size, gives you the creation time of the file, and that's the time stamp that the file has when it's created in your directory. There are also additional columns here: discovery time, commit time, archive time. These are future audit fields that will be populated at some point in time with AutoLoader. Right now, they're not enabled. We should say that. I think there are certain flags that you can trigger that would switch them on. I've been warned not to do that in a production environment. There are performance impacts of having these things turned on. And so they're working on getting that stuff worked out, and it'll be released in a future release, maybe in the next quarter or two. I can't commit to anything, but that will be really nice to see in AutoLoader, to not only see when the file arrived in the directory, but to see when AutoLoader discovered it, when it was committed to its target location, and then when the file was ultimately archived. There's a lot of reporting you can do off of that, and that's what my customer was really interested in. And so, but because these three columns aren't production ready, that's why we were looking at building our own sort of audit table. So as we were depositing our data into our target location, we were also writing data out to this audit record. So you see, we had a rather large zero ingestion. A lot of files were brought in that very first batch. It's still being processed, it looks like. Left things going for a long time. As you can see, older examples, I haven't been clearing out this audit location. This is, every time I delete a checkpoint and everything, it starts over at ingest ID 0. But you can see how some of this ingestion goes over time, pulling in these files within a certain micro batch, and it assigns that ID to it. One thing that you'll see that's interesting, like this one, there's 4 files here that are being ingested. You can see the files were created at 252, 258, 303, 308, about approximately every 5 seconds. And it was all brought in at 313, 2.271. So this was 313, and then AutoLoader detected them at 13.271 and brought all 4 of them in that micro batch. Let's go look at some data. So this is a particular query that I've created that looks at that data. Come on. No results. That's not helpful. You guys get to see me have a blip here. Give me just a second. I'll try to get this restored. If not, we'll, oops, wrong one. I don't think that changed anything. Well, I wonder if I botched something up when I was getting this ready for the demo. What we'd love to see, looks like the audit is working fine. The insert into the table is not working fine. But what we'd love to be seeing right now is those tables, the ingested records, it would have that metadata information in it. It would have a row created metadata on it. And well, maybe, let me see if I can try this. I might be having issues with my row created data meta stuff. So, all right, I'm gonna order by ID. My apologies. I'm not getting any errors. I don't know what's going on. This is what's going on. My filter was filtering everything out. So we have just one record for every piece of data that's coming in. I believe what is happening is that my logic for filtering out my row created metadata column isn't functioning right. And so it's being updated every single time an update is being processed. So I don't get to show that handy dandy logic here to show you how I can see the updates being processed over time. But as we could see with our basic loader, when we saw multiple instances of ID 1000 in the target table, now we only have one instance of ID 1000 in the target table. And so all the updates will get processed through. You can see the most recent file that was updated, what time it came through, or what time it was written out there. And you can go against the audit to see when the commit time was, things like that. So there's a lot of advantages to having this metadata captured here. It helps give you an understanding of where everything's coming from. Additionally, the source helps us out by creating a column with the file name in it. That's definitely not always going to be the case. But there's a lot of flexibility that you get from having this additional metadata and stuff captured out here. I was tweaking this notebook and I must have broken the row created metadata. I was trying to clean it up and make it a little bit more streamlined, and I must have made it so that this is still getting updated when it processes the merge. All right, so I'm going to check. It looks like there is a QA. Yeah, live demo gremlins. I don't know if we have any other questions. Hopefully that all made sense as we're looking at this. So we ingested the record. We performed a CDC merge into the target table so that we no longer get multiple records with the same ID on them. And we created a record in the audit table so that we can see what's going on and how the data is being captured. All right, with that, what I'm going to do is I'm going to go ahead and cut that. I'm going to step over into DLT. Okay. I was worried my VPN was cutting out again, but looks like we're good. So over here in DLT, as I said, DLT will use AutoLoader in the background, and it does a lot of this option and stuff for you automatically. Because of that, it's very prescriptive. And so you don't necessarily get the full flexibility that you have if you're building it out by hand. But it does have a lot of power and it's very simple to use. So as you see right here, what I've done is I've created a streaming live table. And I've built that off of cloud files, which you'll recognize cloud files. That's the AutoLoader library. It's a simple select statement. So I'm selecting star and then metadata. And then I'm also selecting, showing you dot notation here, metadata, and I'm drilling down into the file modification time because it's a named structure, that metadata. And it has a field in there called file modification time. So I'm pulling that out and I'm aliasing it as file time. And so this is that target location. It's the raw, or not target location, it's the raw data, it's the source location. It's CSV format. I'm telling it to infer column types. But then I say that there's also a header, and I go ahead and I just define the schema. So this is sort of like hints. I told it to infer the column types, but then I went ahead and specified the schema myself. So if I left this out, it would just infer the column types. I'm showing you a few of the options all sort of packed in here at once. Then what you do is this will sort of replicate that basic AutoLoader notebook where it brings all the files in and drops them in one place. I've called that table RM coordinates bronze CDC. And it just drops everything into one bucket. You have lots of duplicates. It's that raw data capture insert only. What I'm also doing here is I'm creating a live table I remove that CDC and I make it DLT. And then I'm going to do this apply changes. And this apply changes does everything that you saw with merge in that prior package, all in a simple little statement. So I'm grabbing this new table I created, and I'm inserting into it, and I'm sourcing it from this bronze CDC table. I'm specifying the primary key column, which is that ID column. I'm sequencing it by file type. So that file time, sorry, so that makes sure if there's multiple updates for the same ID, it knows how to sequence it and grab the most recent record. And then it's updating all columns, or it's passing through all columns except for the metadata and the file time. So I'm filtering out those two columns that I grabbed right up front. And everything else will go through that came in the original file. So I have this package here that I built off of this DLT pipeline. I don't have time really to dive into how DLT works, but you basically build a pipeline, which is a job on top of that notebook. I've already run it. So it's going to have some old data in it, but it takes a couple minutes for the clusters to spin up and to run. So I'm not going to turn it on now. But what you see over here is I have that bronze CDC file or records. So you see how that lands there. I have that metadata. I have all 4 columns from the source. I have the metadata, and then I have the file time. And then I'm going to show you, but one of the key things to note, well, you can't really see it here, but you do have duplicates. And then I'm going to run the bronze DLT table, and you can see I lose those metadata columns because I had specifically filtered them out, but you only have 1 record per ID. And I'm going to demonstrate what that looks like here as I join those 2 tables together. I'm joining them on ID, and I'm ordering by ID and file time. And so you can see here, there's multiple records of 1,000 that have come through. This is the most recent one up top, and you can see that they match across. These would have been older records that come through, and you see that they don't match. This is the current one in the DLT in the merge table, and this is the prior record that it come through with different values. As we scroll down, you see 1001. Once again, this is the most recent update record that came through. And you can see that the 2 instances match across it. So it was updated to reflect the most recent record. Anyway, so that's a blitz through of AutoLoader and several different ways in which you can approach building out an AutoLoader solution and doing data ingestion. AutoLoader can be really quick and simple. It can be pre-packaged in DLT, or you can build it out yourself and give yourself all sorts of capabilities of writing to multiple syncs and performing CDC and applying all sorts of transformations and logic that you want to it. And it's a very versatile and scalable solution. That said, I'm going to take a break. We've only got a few minutes left. I'm personally fine with sharing these notebooks. I've got 3 notebooks here, and so I can provide them.
That'd be great. If you just want to send those to me, I will attach them to the follow-up email with the recording.
Okay. So I know we're running out of time. I don't know if anybody has any last-minute questions. I hope this was helpful to everybody to see how you can use AutoLoader in your tools. Apologies. All right, sorry. Little dog got excited. All right, I'm going to go ahead and stop sharing.
Thank you, everybody. Have a great week.
Yeah.
Thanks, Robert.
Thank you.